Now that you know how to figure the azimuth of sunrise and or sunset, let's see what you can do with that information. You don't have to be up at sunrise, or you don't have to actually visualize the sunset for that information to be useful to you. On any given day, provided the sun is of course visible, you can determine where on the horizon it rose or where it will set by using a simple technique in which you imagine tracing the sun back to the horizon along its rising or setting angle. This technique is useful up to about 2 or 3 hours after sunrise, or within about 2 or 3 hours before sunset. As you'll soon see, this ability will prove very useful in finding your way. Before I go any further, here's a safety warning. Never look directly at the bright sun. I can't overemphasize this point. Its powerful rays can quickly damage your vision. So when using the sun to find directions, always ensure that it is covered sufficiently to prevent eye damage. Okay, now that the safety rule is in place, here's how to find where the sun rose or where it will set. Stand between the sun and a conveniently distant tree so that the tree safely covers the sun and any eye-damaging rays. If no such tree is available, use your hand, a plate, or any other suitable object to safely cover the sun. Then, in your imagination, draw a line from the sun back to the horizon, in the case of sunrise, or forward toward the horizon, in the case of sunset, along an angle equal to 90 degrees minus your latitude. Where that line touches the horizon is where the sun either rose or where it will set, depending of course on whether you're using the morning or the afternoon sun. Of course, you don't have to use a tree to help you trace the sun back to the horizon, but I often like to just use a tree because it's an easy way to do it. In the absence of a tree, just cover the sun with your hand or something that will properly cover it, and then in your mind's eye trace a line back to the horizon at 90 degrees minus your latitude. Now, speaking of 90 degrees minus your latitude, I want to show you some examples of sunrises and sunsets from around the world so that you can see exactly how this 90 degrees minus your latitude thing works. Here's an example of a sunrise very near the equator. If the sun rises at 90 degrees minus your latitude, if you're, we'll say right on the equator, the sun's going to rise at 90 degrees minus 0 degrees, so it's going to rise at a 90-degree angle. And of course, 90 degrees means it's perpendicular to the horizon, and a 0-degree angle would be parallel to the horizon. So let's watch the sun come up here. You see it's coming almost straight up, and that's what happens around the equator. And so now we'll look at a sunset near the equator. You see it's coming straight down. Now let's go to about 30 degrees north latitude and watch the sun come up from there. You can see it's coming up at about a 60-degree angle, and since we're in the northern hemisphere, the sun is going off to the south. And also here at 30 degrees north latitude, we see the sunset coming down at about a 60-degree angle, and it crosses the horizon a bit north of west. Let's go now to up near the Arctic Circle, and let's see an August 31st sunrise. Of course, since it's August, the sun will be coming up somewhere north of east. So let's just watch the sun come up. You see the very shallow angle at which it rises. So if the Arctic Circle is at 66.5 degrees, the sun would rise at approximately 23.5 degrees, which is, of course, 90 degrees minus the latitude of 66.5 degrees. And that angle is approximate. Let's look now at sunset on that same day, once again up around the Arctic Circle. So here comes the sun coming in at a very shallow angle. Comes in at a very shallow angle, and it crosses the horizon. Now you notice that it remains twilight up in the Arctic much longer than it does, say, down in the tropics, because that's because of the shallow angle that the sun crosses the horizon. And after crossing the horizon in the Arctic or up farther north, the sun hangs out right under the horizon for a lot longer time than it does in the tropics, where the sun just drops straight down. So that's why you have a lot longer periods of twilight up north or way down south than you do more around the equator. Since you now know how to estimate very closely the azimuth of sunrise and sunset, you can couple that knowledge with the ability to trace the sun back to where it rose or forward to where on the horizon it will set, and that means that you know the azimuth of a single spot on the horizon. And knowing the azimuth of any single spot on the horizon means you know the azimuth of every spot on the horizon. So we're now going to, in the next lecture, see how to use this to help us navigate around the terrain, usually within about an accuracy of about 10 degrees.